Brian and I wanted to demonstrate a process where we build a flowchart, convert it to pseudocode. And we thought that a really fun example would be a basic sorting algorithm. Now, before I get any crap from people, yeah, this is a horribly inefficient sorting algorithm and you should never use it for any circumstance except for as a learning tool. It's a simple swap sort. Do your research. It's the worst algorithm that exists. But it's the easiest to explain to someone that's just entering software development. If you look on the right section where we have our list, this is our array. We have an array and the values are 1, 2, and 0. And we want this to be ordered from 0, 1 to 2. So what I want to do is just kind of walk through this algorithm, and we'll just kind of go through step by step, and then we'll port this into pseudocode. So the first thing that we do is we take our list in. So the required parameters is the actual list itself. Then we start our data off as setting I equal to 0. You guys can kind of see this kind of has the structure of a for loop. Keep that in mind. And the length of our array is going to equal 3 because there's 3 items in the array. So once we've gotten through this section, we're going to go to our decision. Is I less than length minus 1. So is 0 less than 2? In this case, the answer is yes. So we fall over here to the yes condition. Now we're going to evaluate, does the current item that we're looking at, is that greater than the next item in the list? So in this case, it's not because 1 and 2 are already in order. We're actually going to fall into the no condition here, which increments I. So then I will equal 1. We come back now into the decision structure. You guys can see how this loop is forming. Now I equals 1, length still equals 3. Is I less than 2? Yes. Okay, let's fall to the next condition. So basically what we're saying is we have not reached the end of the list. In this condition, is the current value greater than the next value? And the answer now is yes, because you could see that 2 is greater than 0. So what do? We perform a swap operation. The swap operation is simply storing one value in an array, setting that value equal to the next value, and then resetting the current value to the stored value.
So we'll use the temp variable as a placeholder to hold the value that we overwrite. So where 0 is, we hold it in a temporary holding place, and we copy 2 up to 1, so now it's 1, 2, 2, and then we take from the holding place 0 and put it back to 2.
So now if you look on the upper right where we have the yellow text, you can see that 0 and 2 have been swapped. So now 0 has been moved above 2. And now we're going to set the incrementer back to -1. Now, for those of you that may be confused, you'll see at the next operation, we increment I. So even though we set it equal to -1, when we go back to our iteration, we set it back equal to 0. So now we're going to the top of the list to reevaluate it.
So in other words, every time we perform a swap operation, we start all over again in the list.
Yep, exactly. Which is why this is a horribly inefficient algorithm. All right, Brian, let's take us through the next set.
Now I is set to 0, and we're going to run through this again. So now we check the decision. So I is 0. Is it less than the length minus 1, which is 2? Yes, it is. So now we're going to drop down to the bottom, and we're going to evaluate the contents of those positions. Is the current position, which is 0, greater than the next position, which is 1? 1 is greater than 0, so that falls into the yes condition. Now we're going to perform another swap operation. So we're going to temporarily store the value off and switch it. So we're going to swap 0 and 1.
So now look at the list, guys. The list is actually in order now.
Yes. Now, because we've performed a swap operation, we've set the incrementer back to 0, and we're going to start this whole thing over again. We test this and say, is 0 less than the length? It is. So now we evaluate to see if they're in order. Is 0 greater than 1? No, it's not, so we go to the next one because they're in order. So we increment, we check to see if we're at the end of the list. We're not. We go to the next one, and we see if they're in order. Is this one greater than the next one? No, it's not. They're in order. We go back. Are we at the end of the list? Is 2 less than the length minus 1? 2? No, it's not. So now we're going to hit the no condition because we're at the end of the list. We've not performed any swap operations, and everything seems to be in order. So now we're going to return the array in its sorted form.
How cool is that?
Done.